Assalamualaikum and good morning everyone. Today we are group 11. We will be presenting our PBL assignment. Specifically, we will cover set question number 10. Before we begin, I'd like to highlight that for each task in this presentation, question number 3 will be presented by Muhammad Sirajuddin Alwi, who is also our group leader. We hope you'll find our presentation engaging and informative. Let's begin. So task 1. A warehouse has an initial storage capacity of 1,000 units and plans to expand by 100 units by each year. So the question is, what will the capacity be after 6 years? So we get the n equal to 6. So A is the first term. First term of the capacity is 1,000, and D, common difference, is 100. So we are going to use this equation, which is Tn equal to A plus n minus 1 multiplied by D. We just insert the information that we get into the formula. So T6 equal to A is thousands plus n is 6 minus 1 multiplied by D is hundreds. So after calculation, we get T6 equal to 1,500 units. That is the capacity after 6 years. So we move on to the second question of the task 1. So find the total storage capacity accumulated over 8 years. So this involves calculating the total of the storage capacity for each year after 8 years. This can be thought of as the sum of an arithmetic sequence. So here we got as n equal to 8. First term is 1,000, and D, the common difference is 100. So we are going to use Sn equal to n over 2 multiplied by 2a plus n minus 1 multiplied by D. That is the formula, and we just insert the information that we get from the question to the formula. So we get S8 equal to 8 over 2 multiplied by 2 multiplied by 1,000 plus 8 minus 1 multiplied by 100. So after the calculated, we got 10,800 units. So that is all from me. I will pass it to Muhammad Sirajuddin to continue presenting question number 3 for task 1. Thank you.
Hi, my name is Muhammad Sirajuddin Alwi bin Rosli. My matrix number is A240594. Okay, if the demand grows faster than the warehouse plant expansion, several strategies can be implemented to adapt effectively. First, the warehouse could rent additional storage space temporarily to handle peak demand without compromising operations. Another approach is to optimize inventory management systems, ensuring the current storage space is utilized more efficiently while reducing idle stock. Accelerating the construction process using faster building techniques or modular designs is also a viable option to expand capacity more quickly. Lastly, decentralizing operations by opening smaller, strategically located storage facilities closer to high-demand areas could also help reducing the logistical challenges and meet the growing demand effectively.
Assalamualaikum and hello everyone. My name is Muhammad Nur Iman Mir Zainal, matric AA241071. So I will explain to you about our task 2 for our PBL assignment. So, a production line produces 200 units in the first hour, increasing by 15 units every subsequent hour. First, calculate the production rate at the 5th and 10th hours. So basically we already know based on the questions that initial production rate is A equals to 200 unit per hour, while the common difference that is D equals to 15 unit per hour. So based on the question, they also give N that is 5, 5th and the 10th. So we use it and transfer it and add the formula that is X n equal to A plus D n minus 1. So for n equals to 5, it means that x5 equals to 200 plus 15, 5 minus 1, and then you get a 260. While the 10th one, that n is equals to 10, x10 equals to 200 plus 15, then 10 minus 1, so you can get a 335. So it's easy for you to do it, just follow the rules and you can make it up. So the question number 2, determine the total units produced by the end of 8 hours. As you can see, and on the questions, they already given the total units produced by the end of 8 hours. That is the key point for our questions. So for n equals to 8, so you can use it, the formula that is Sn equals to n plus 2 multiplied by 2a plus n minus 1 multiplied by d. So we change the equation, and that is n2 equal to 8. So S8 equals to 8 per 2 multiplied by 2 and multiplied by 200 plus 8 minus 1 multiplied by 15. So we already get 4 multiplied by 400 plus 105. So and then you can get the last answer, that is 223 units. So that's all from me. Thank you.
Now, let's talk about the potential impact of machine wear on a production line. Over time, as machines experience wear, the production rate would gradually decrease, leading to reduced efficiency. To address this, we can develop a model that factors in this wear. For example, while the initial production rate is set at 200 units per hour with an increment of 15 units for each subsequent hour, we can introduce a wear factor that gradually reduces this increment as time progresses. To mitigate this issue, the production line could implement regular maintenance schedules to ensure machines operate at their peak efficiency. Upgrading equipment or integrating automated system could also help maintain consistent output over time. By proactively addressing where the production line can sustain reliable performance despite the challenge.
My name is Muhammad Farish bin Faizal, matric number AA 240821. Today I can explain task 3, question number 1 and 2. A production line double is the output each hour starting at the 200 unit. Question 1, find the production rate at the 4th and 7th hour. The formula we use 200 multiplied by 2 power n minus 1 represent a geometric sequence where 200 is the first DAM and the common ratio is 2. The variable n represent the number of hour. The calculation for the fourth hour is accurate by 200 multiplied by 2 power 4 minus 1. We get 200 multiplied by 22, finally we get 1600 unit. For the 7 hour is also accurate, 200 multiplied by 2 power n minus 1. We get 200 multiplied by 2 power 7 minus 1. We get 200 multiplied by 26. Finally, we get to 12,000 at 100 units. That is question number 2. Calculate the total unit produced over the first 5 hours. The second method uses the sum formula, a geometric sequencer Sn a Rn minus 1 division by R minus 1, where A is the first them, R is the common ratio, and N the number of them. In the question 2, A is 200, R is 2, and N is 5. We use Sn a Rn minus 1 division R minus 2. S5 equal to 200 multiplied by 35 minus 1 division 2 minus 1. After that, we get 200 multiplied by 200 multiplied by 32 minus 1 division by 1. After that, we get 200 multiplied by 31. Finally, we get 6,200 units.
Finally, let's evaluate the practicality of doubling production output of each hour. While this strategy might seem appealing in theory, it is highly impractical in a real-world setting. The exponential growth in output would require an equally exponential increase in raw materials, manpower, equipment, and energy, all of which are limiting resources. Additionally, managing and storing the exponentially growing output would create significant logistical challenges. To optimize production, a more realistic approach would be to adopt a logistic growth model. This model allows production to grow steadily while slowing it as approaches resource or demand ceilings. The production line could focus on scaling incrementally by adding capacity based on real-time demand and resource availability. Leveraging automation and AI could further optimize resource allocation and scheduling. Then, regular evaluations of production performance would also ensure operations remain aligned with the market demands and resource constraints.